Now next topic of this chapter, plane. See, in this chapter we discussed about line in space, various results, equations, formulas for line in the space. Now the remaining part of chapter is a plane in the space. First result is equation of plane in normal form. Equation of a plane in normal form. So here, because everything we are doing in space, this is x-axis, this is y-axis, and suppose this is z-axis. These are coordinate axes. Here we consider this plane. This is a plane. Now if I take perpendicular from O to this plane, suppose that this is foot of perpendicular. Let me say this point is M. This is said to be normal to this plane. I am putting here N. And if I show here directed line segment ON, then this vector, because it is perpendicular to this plane, this is perpendicular to this plane. I am showing symbol of perpendicularity. This is perpendicular to plane. This is said to be normal to this plane. Any vector which is perpendicular to plane, it is said to be normal. So first statement I am putting here, meaning of normal: any vector perpendicular to the plane is said to be normal to that plane. Now we are taking a unit vector in the direction of normal. Suppose this is unit vector in the direction of vector ON. So we say this is unit normal. This vector is unit normal. Suppose length of this perpendicular from origin to this plane, this length is D, distance is D. If perpendicular distance of plane from origin, or we can say length of normal taken from origin, or length of normal taken from origin, if this length is D and this is unit normal, and for unit vector we use this symbol. I am simply speaking a cap, n cap is, or unit vector n. So unit normal, n cap is unit normal to the plane. So D is distance or length of normal or length of ON, and this is a unit normal. then equation, vector equation of a plane is vector r dot n cap is equal to d. Remember, in this formula, this is unit normal and this is distance of plane from origin. So it is vector form. This is vector form of equation of plane. Vector r. Now what is vector r? Vector r is position vector of any variable point. If P is any point on this plane, its position vector is vector r. Then it is position vector of any variable point. So vector r dot n cap equal to d. It is vector form. N cap is unit normal. Now see, if vector r, it is xi plus yj plus zk. If I keep here xi, yj, zk, and if suppose this unit normal, if I represent by li plus mj plus nk, then putting values here, dot product of these two vectors is lx plus my plus nz, it is equal to d. This is Cartesian form. It is Cartesian form of equation. And say here, because this is unit normal, L, M, N are direction cosines of this unit normal. So because it is unit normal, in this equation L square plus M square plus N square is 1. So whenever you have any equation in Cartesian form and sum of square of these coefficients is 1, then and only then this d represents distance. Okay, remember this statement. Whenever you have equation of plane in Cartesian form and sum of square of these coefficients is 1, then and only then d represents distance of a plane from origin. But sometimes if equation of plane is in equation of a plane, suppose I take here ax plus by plus cz equal to d. If sum of squares a square plus b square plus c square, sum of squares of these coefficients, it is not equal to 1, then in this equation d does not represent distance of plane from origin. Then d is not equal to distance of plane from origin. So remember, every time whatever is constant on the right hand side, that constant d doesn't represent distance. To say it is a distance, sum of square of these numbers is 1, then and only then this is a distance. But if sum of square of coefficients is not 1, d does not represent distance. So here in this equation, here A, B, C are direction ratios. These are direction ratios of normal ON to the plane. So ABC are said to be direction ratios. So to convert this equation into this form, we have to divide this equation by magnitude of vector obtained by these numbers. So to obtain distance of a plane from equation, let me say this equation is 2, this is 2, this equation is 1. So to obtain distance of plane from equation 2, we divide equation 2 by magnitude of vector n, where vector n is, that is normal. So it is AI plus BJ plus CK. This is what? It is vector normal vector. This is vector n. The symbol, say I am differing symbol. This symbol is for vector n. Here in diagram we can say ON. This vector is vector n, normal vector, and this is unit vector. So in this result unit vector is used. These are direction ratios of unit vector, and here ABC are direction, these are direction cosines. LMN in this result are direction cosines. If n cap is Li plus Mj plus Nk, LMN are direction cosines, because sum of square is 1, and here sum of square is not 1, so coefficients are not direction cosines, they are direction ratios of this vector n. This is vector n. So difference between vector n and normal, unit normal. This is simply, we are speaking normal. This is unit normal. N is normal, and this is unit normal in this discussion. So to obtain a distance of a plane from equation 2, because this D does not represent distance, what we do? We divide this equation by magnitude of normal, where normal is AI plus BJ plus CK. So in this case, here A upon magnitude n times x plus B upon magnitude n times y plus C upon magnitude n times z equal to D. And this must be positive, D upon magnitude n, and this must be positive. It must be positive. Then this value is a distance, and these are direction cosines. So whenever any equation is given in this form, this is the procedure to obtain distance of plane from origin. So if this is positive, here I am changing words. If it is positive, then it is distance. distance of plane from origin. Now see, in this question, find the vector equation of a plane which is at a distance of 7 units from the origin. So distance from the origin is 7 units and normal to the vector, that is normal vector n, it is equal to 3i plus 5j minus 6k. This is a normal. So here sum of square of these three numbers is not 1. So it is not a unit normal. And we want to use unit normal in the result. So to obtain unit vector in the direction of vector n, we divide this vector by its magnitude. So magnitude of vector n is square root of 3 square is 9, 5 square is 25, minus 6 square is 36. That is 25 plus 9 is 34. 34 plus 36 is 70. So square root of 70. Therefore, unit normal is vector n divided by its magnitude. That is 1 upon root 70 times vector n is 3i plus 5j minus 6k. So that is 3 upon root 70 times I, 5 upon root 70 times j, 6 upon root 70 times k. This is unit normal. It is a unit normal. Now required equation is, we are asked vector equation. Vector equation of plane formula is, now we are having a unit normal and distance from origin. This is distance from origin. So vector r dot unit normal equal to d. So that is vector r dot, now putting this value, 3 by root 70 times I plus 5 by root 70 times j minus 6 by root 70 times k. R dot n is equal to d. D is 7. So this is required vector equation. In this question, find the direction cosines of the normal to the plane and distance from the origin. Say, look this equation. So here equation is in this form, ax plus by plus cz equal to d. See, observe these numbers. Coefficients 2, 3, minus 1. See, these are numbers whose sum of square is not 1. So these are not direction cosines of unit normal. So we can say these numbers are direction ratios of normal. So here direction ratios are here, because these are direction ratios of normal. So normal is equal to, see, I am not putting a unit normal, simple normal, 2 times I plus 3 times j minus 1 times k. Just discuss in theory that if equation is ax plus by plus cz equal to d, a, b, c are direction ratios of normal. So normal is ai plus bj plus ck. Now we want direction cosines. So finding its magnitude. Magnitude is square root of 4 plus 9 plus 1. So square root of 14. Therefore, direction cosines of this normal. Direction cosines of normal n are 2 by root 14, comma 3 by root 14, comma minus 1 by root 14. These are direction cosines. So sum of square of these numbers is 1. Now to find distance from origin, we have to convert that equation in this form. R bar dot n cap equal to d. That means if equation is in this form, Lx plus my plus nz equal to d, where if Lm and are direction cosines of normal and this number is a positive number, then this represent distance. So what we do to convert this equation into this form, we divide this given equation. So from given equation we are dividing by root 14. So 2 by root 14 times x plus 3 by root 14 times y minus 1 by root 14 times z equal to 5 by root 14. So see, this equation is now in this form. Here L, M, N are direction cosines. If L, M, N are direction cosines and this number is positive, then it represents distance from origin. So which is of the form, Lx plus my plus nz equal to d, where L square plus m square plus n square is 1. If equation given in this form such that sum of square of these three numbers is 1, if this number is positive, then and only then this is a distance. So here a distance from origin is 5 by root 14. Now in this question, z is 2. So this equation, you can see that 0x plus 0y plus 0z equal to 1z. This can be seen by this way: 0x plus 0y plus 1z is 2. Now observe these equations. See, sum of square of these numbers is 1. See here, 0 square plus 0 square plus 1 square is 1. So therefore these are direction cosines. Therefore 0, 0, 1 are direction cosines of normal. Means equation is in this form, where L square plus m square plus n square is 1, and if so, this is a distance. But say this must be positive, d must be positive, otherwise you have to change the sign of equation. So and distance is 2. So this is distance from origin. Find Cartesian equation of a plane. See, equation of plane is in vector form. Vector r dot vector n equal to 1. So here to convert into Cartesian form, we put we are putting vector r equal to xi plus yj plus zk. This is a position vector of any variable point. Position vector of any variable point. Now putting here, so we have xi plus y times j z times k dot 2i plus 3j minus 4k is 1. That means taking a dot product, 2 into x is 2x plus 3y minus 4z equal to 1. This is Cartesian equation. Simple. R bar dot vector r dot vector n is d. Then 2x plus 3y plus minus 4z. 2x plus 3y minus 4z. So directly also you can show this Cartesian form if short questions are asked. 2 into x plus 3 into y minus 4 into z is 1. Simple. Similarly here, if we put vector r xi plus yj plus zk, then putting here xi yj zk dot, this is like ai plus bj plus ck. So ai plus bj plus 2s plus t, that is ck, equal to 15. Now taking a dot product of these two vectors, x into this number, so s minus 2t times x plus 3 minus t times y plus 2s plus t times z equal to 15. This is Cartesian equation. Now here find coordinates of the foot of perpendicular drawn from the origin. So here suppose this is x-axis, this is y-axis, this line is z-axis, and here this is a plane whose equation is given, and taking perpendicular from origin, this is O, if P is foot of perpendicular, P is a point which is foot of perpendicular taken from origin. We want coordinates of foot of perpendicular. So suppose that coordinates of P are x1, y1, z1. Suppose that coordinates of the foot of the perpendicular P, which is drawn from coordinates of the foot P of the perpendicular drawn from origin. Suppose coordinates are x1, y1, z1. These are coordinates of P. So from this direction, from this diagram, we can say that therefore direction ratios of normal is vector AP. Direction ratios of normal is x1 minus 0, x1 minus 0, comma y1 minus 0, comma z1 minus 0. So these are direction ratios of normal. That is x1 comma y1 comma z1. This is from diagram. Now from this equation, 2x plus 3y plus 4z minus 12 equal to 0. From equation of this plane, observing these coefficients of x, y, z, we can say that direction ratios of same plane, direction ratios of normal to the same plane are 2, 3, 4. If equation of a plane is ax plus by plus cz equal to d, a, b, c are direction ratios. So from equation, because equation is given, direction ratios are 2, 3, 4. And these are direction ratios of same plane. x1, y1, z1 are also direction ratios. These three numbers are also direction ratios of normal OP. For every vector we can write infinite many sets of direction ratios, but all these triplets are in proportion. So therefore x1 upon 2 equal to y1 upon 3 equal to z1 upon 4. These three numbers and these three numbers are in proportion. So suppose that it is equal to k. We say it is equal to k. Therefore x1 is 2k, y1 is 3k, z1 is 4k. So coordinates of P are, therefore P is 2k, 3k, 4k. These are coordinates of P. Now this point lies on this plane, which lies, this point lies on 2x plus 4y plus 2x plus 3y plus 4z minus 12 equal to 0. And if any point lies on the plane, coordinates of that point will satisfy equation of plane. So P is a point on this plane, so coordinates of P will satisfy equation of this plane. So putting here x equal to 2k, so 2 into 2k is 4k, 3 into y, 3 into 3y is 9y, 4 into 4z is 16z, minus 12 equal to 0. So here I am showing in detail. That means 2 into 2k, 3 into 3k plus 4 into 4k minus 12 is 0. Therefore this is 4k plus 9k plus 16k, that is 29k is 12. So k is 12 by 29. 12 by 29 now I am putting in this equation. So therefore coordinates of P are 2 into 12 by 29 comma 3 into 12 by 29 comma 4 into 12 by 29, that is 24 by 29. 36 by 29, 48 by 29. So these are coordinates of foot. Now next result, equation of a plane perpendicular to given vector. Let me say vector n. We can say it is normal and passing through a given point whose position vector is vector A. If a plane is given and there exists a vector which is perpendicular to this plane, every vector perpendicular to plane, it can be said as normal. This is given, and a point through which this plane is passing, position vector of this point is, suppose if somewhere here this is x-axis, this is y-axis, this is z-axis, then position vector of this point is vector A. Here this vector is vector A. So position vector of a point on plane is vector A. So a point is given and perpendicular vector is given, then equation of this plane is vector r minus vector A dot vector n equal to 0. This is vector equation. It is vector form. Now, if we keep vector r is xi, yj, zk, if vector is x1i, y1j, z1k, vector n is ai plus bj plus cz, ck. If we use this traditional symbols, then we can say that Cartesian equation of plane, Cartesian equation of a plane perpendicular to normal ei plus bj plus ck and passing through a point A whose coordinates are x1, y1, z1. If coordinates of A are x1, y1, z1, here if coordinates of A are x1, y1, z1, then position vector of this vector will be x1i plus y1j plus z1k. So now I am converting this form into Cartesian form. So Cartesian equation of plane perpendicular to this vector, perpendicular to this vector n, which is normal, and passing through a fixed point x1, y1, z1 is, see, from this equation you can learn r minus a dot n vector n is 0. So r minus a, that is x minus x1. So x minus x1 into, say here dot product is with n, that is a, So a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. So this is Cartesian equation. Now I am taking question which is based on this result. Find a vector and Cartesian equation of a plane passing through 1, 4, 6 and normal to the plane is I minus 2j plus k. So here plane is passing through 1, 4, 6. So vector A is 1i plus 4j plus 6k. This will be position vector of that point through which plane is passing. Then normal to the plane, that is vector n, is I minus 2j plus k. This is vector form. So vector equation of plane is, formula is vector r minus vector a dot vector n is 0. That is vector r minus vector a is I plus 4j plus 6k, r minus a close bracket dot vector n is I minus 2j plus k equal to 0. This is vector form. R then minus vector a close bracket dot n is 0. Now for Cartesian equation we use this form. Now for Cartesian equation, so here x1 y1 z1 is 1 4 6. Then ABC is 1 minus 2 1. These are direction ratios of normal. A, B, C, that is from normal. x1 y1 z1, that is coordinates of given point. Now I am putting this formula. So Cartesian equation is A into x minus x1 plus b into y minus y1 plus c into z minus z1 is 0. That means A is 1 into x minus x1 plus b is minus 2. So minus 2 into y minus y1 is 4 plus c is 1 into z minus z1 is 6 equal to 0. That is, it is x minus 2y plus z, and see now calculate constants. Minus 1 plus 8, so 8 minus 1 is 7 minus 6 is 1, so left is plus 1 equal to 0. This is Cartesian equation.